It is too soon to say whether or not these miracles have an extraterrestrial origin, because we have only just gotten visual access to the astonishing and bizarre events taking place outside of our own planet. The James Webb Space Telescope is exceeding everyone's expectations at NASA in terms of its performance. In July 2022, not long after it was made available for exploration, the observatory immediately began transmitting breathtaking photos of the cosmos. Researchers are able to examine planets that orbit other stars with the help of these photographs, as well as keep an eye on Earth and the other planets that are part of our solar system, and look back into the distant past to discover more about the beginnings of the universe. Here in this video, we'll be talking about the 10 insane images captured by James Webb Space Telescope. Subscribe to this channel if you're ready to take a deep dive into the vast unknown with me as we explore the most insane images from outer space. Let's get started. Number 10. The glowing Jupiter. Hinted at the new degree of detail and accuracy that would be seen in the picture of Jupiter. Jupiter's cloud cover rings and moons have been revealed in more detail than scientists had hoped for in recent photographs given by NASA. When questioned regarding the caliber of it, the astronomers responded that they were pleasantly taken back by it. To transform infrared radiation into colors that can be seen, the telescope makes use of a camera that is fitted with 3 different filters. The auras of Jupiter, which are only visible from Earth with the help of a red filter, could be observed at either pole of the planet. The light that is reflected by dense clouds result in the production of colors that are found in the blue spectrum. In addition, a green and yellow filter draws attention to the unusual atmospheric hazes that exist on the planet. Because it is so brilliant, the Great Red Spot, which is a storm that is larger than Earth, makes the planet Earth appear to be white. NASA hypothesizes that the white streaks and patches on the moon are caused by sunlight reflecting off the clouds located at very high altitudes. The blurry rings and 2 moons that orbit the planet are currently being dissected by researchers using zoomed-out images of the planet. Number 9. Small concentration of dark matter. This image of the huge MAC SJ1206 galaxy cluster was acquired by NASA's James Webb Space Telescope. It features views from distant background galaxies that are portrayed as arcs and hazy features. Light coming from extremely far-away galaxies are amplified and warped by the gravitational pull of the cluster's dark matter, which is the root cause of these aberrations. Using this phenomena, astronomers are able to study galaxies that are exceedingly far away and very dark. Dark matter is the unseen substance that binds galaxies together, and its minuscule concentrations, which are superimposed just on the image, make up the majority of the material that exists in the universe. According to the findings of the Webb Space Telescope, these blue halos appear to be a reflection of the distribution of dark matter throughout the galaxy cluster. Astronomers were able to accomplish this by determining the extent of the gravitational lensing effect. Number 8. MACS J0717. An extraordinarily expansive image of the galaxy cluster known as MACS J0717.5 plus 3745, as seen by the James Webb Telescope. James Webb pieced together the massive panoramic by using 18 individual photographs. Scientists have discovered a filament of dark matter that extends from the center of the cluster through an examination of the gravitational effects that are induced on the background galaxy light. On a mass distribution map depicted in blue, the amount of dark matter is shown in concentration. It is possible to make out the filament as it moves away from the nucleus of the center to the left. The team has, for the very first time, generated a 3-dimensional map of the filament structure. This was accomplished by using the additional observations obtained from ground-based telescopes. Since we are aware that the filament extends away from the cluster's center, our view is along its length. Number 7. Birth of our galaxy. Around 12.7 billion years ago, when our Milky Way galaxy was still young, globular star clusters covered the sky rather than grand spiral arms. The Milky Way was created when hundreds of globular star clusters that already existed merged together to form a singular larger cluster, such as the blue cluster can be seen at the top left. Scorpius is the constellation that contains this group of stars, which is today referred to as the globular cluster M4. Webb was contracted by astronomers to locate the white dwarf remnant stars, which are the cluster's oldest and have the highest burning rates. The temperature of dwarfs are utilized in the calculation of how long ago a cluster was formed. This method was utilized in the creation of this artwork, which represents a youthful cluster that is full of blue and white stars. There is a newly generated supermassive black hole that can be seen to the right of the center of the galaxy, but it is masked by a halo of dark dust lanes. A powerful jet of stars, gas, and dust is being ejected into space by the newly formed black hole, which has consumed nearby gas, dust, and stars. Pink bubbles of hot gas are created all around a stellar cluster as a result of supernova explosions that are triggered by the most massive stars in the cluster. Number 6. Dark matter in a large galaxy cluster. Within the larger supercluster, the dark matter has organized itself into 4 separate clusters. According to the findings of the study, such locations are consistent with the motions that were expected for hundreds of galaxies that were heading within from the supercluster's outskirts. This picture of a collection of galaxies known as a supercluster was created by combining infrared data from the James Webb Space Telescope with a map of dark matter. One of the largest regions of the sky of the James Webb Telescope has ever captured an image is known as the Abell 901-902 galaxy region, and this image is part of the survey that the telescope performed on that region. Because the inspection area is so big, we took 80 pictures of it so we could post them online. Number 5. A rare cartwheel. A breathtaking cartwheel galaxy is featured in one of the official photos that have been released thus far by the James Webb's team. The rare ring-shaped galaxy that can be found in the constellation Sculptor is located at a distance of 500 million light-years away and was created as a result of a collision with another galaxy that has since left the region. The second galaxy triggered a reaction by reaching the center of the cartwheel, which is analogous to throwing a stone in a pond. At first, the material was driven into the periphery, but then it was directed back towards the center. The most recent images revealed a great deal more clarity in the central ring as well as the fringes, which is where the stars are beginning to emerge. The dust that is being heated as a result of the star formation is brought into sharp focus by the mid-infrared vision. Photos taken with Hubble and older optical telescopes don't show the full extent to which the dust is heating up. Between outer and inner rings are separated by thin filaments, which are primarily composed of silicate dust. A supermassive black hole sits in the heart of a dazzling core. This black hole consumes stuff from its surroundings and, in the process, emits radiation. Number 4. Ghost lights from Abell 2744. The huge galaxy cluster Abell 2744, which is also known as Pandora's cluster, appears to have a spectral appearance in this image captured by NASA's James Webb Space Telescope. The overall image was processed using a computer effect that gave everything a blue tint, including the stars. As a consequence of this, we're able to discern that the beautiful blue-white blobs, which we identify as galaxies, also known as the cities of stars, do not contain all of the starlight in the universe. As can be seen in the areas of darker blue, there is some starlight that has been diffused across the cluster. These galaxies were torn apart eons ago by gravitational forces within the cluster, which results in the stars of the galaxies being dispersed throughout the intercluster space and cause them to produce these rays of light. They are not bound to any one galaxy, and as a result, they are free to go anywhere inside the cluster. Because the light emitted by these extremely dim stars is most prominent near infrared wavelengths, the infrared sensitivity of the Webb Space Telescope was absolutely necessary for the completion of this inquiry. In this picture, every galaxy that is not part of the blue cluster may be found either in the foreground or the background. Number 3. The Stephan Quintet. A group of 5 galaxies called Stephan Quintet can now be observed at a level of detail that was previously unattainable. This massive mosaic is Webb's largest image to date, encompassing approximately 1/5 of the Moon's diameter, according to a statement that was made by NASA. The picture includes approximately 150 million pixels and was created by compiling 1,000 separate image files to make up the final product. Because of its highly potent infrared vision and extraordinarily high spatial resolution, it reveals aspects of the galaxy group that have never been seen before by humankind. This image is filled with starburst regions, which include recent occurrences of star formation, as well as glittering clusters that contain millions of newly formed stars. These elements combine to make the picture look very stunning. In addition, Webb was able to take pictures of massive shock waves that were produced when one of the galaxies, NGC 7318b, collided with a galaxy cluster. James Webb Space Telescope was able to see through more cosmic dust and unveil the mysteries of galaxy mergers or galactic formations, thanks to the use of an additional NIRCam composite image to make the image.
Number 2. Astronomical cooperation.
The aftermath of a Big Bang was just so catastrophic that it imprinted the fundamental structure of a cosmos with an incredible mark. By looking at the light shed on the events of the past, we may perceive these wounds even in the present. After only 14 billion years since its origin, This light, which is now formed in the form of weak microwave radiation and has been given the term cosmic microwave background, or CMB, has spread to cover the entire universe with photons that can be detected. The Sunyaev-Zel'dovich effect has been around for more than 30 years, and it allows astronomers to use cosmic microwave background as a cosmic probe. After making their way through space, the microwave photons that are released by the CMB can eventually be detected on Earth. Although there are electrons with high energies in the galaxy clusters that these items travel through on their way to Earth, the contribution that these electrons make to the total energy of photons is negligible. The detection of these enhanced photons with today's telescopes is a challenge, but it is absolutely necessary for scientists who are attempting to comprehend topics such as the position of dense galaxy clusters. Number 1. The Phantom Galaxy. The Phantom Galaxy, also known by its more popular designation of M74, may be found 32 million light-years distant in the constellation Pisces. In contrast to the photographs obtained by Hubble Space Telescope, those obtained by the James Webb Space Telescope were able to see through the clouds of gas and dust that are located at the galactic core and reveal the star clusters that are located there. In addition to this, the spiral's arms act as a window, allowing one to see the stars as well as other objects that are in the night sky. When combined, the observations from both space telescopes might provide astronomers with the most information possible about the universe. Furthermore, the intriguing center of the Phantom Galaxy can be seen in a variety of guises when viewed through different wavelengths of light, including visible and infrared. Thank you for watching. If you have any questions, let us know in the comments section. Also, at last, give a like to this video. See you soon.